What's up guys, and welcome back to my channel. Today I have a really good video for you regarding how to tackle statistic questions when they involve equations. We're going to start with a very important table that you need to know everything about. So we've got disease status and we've got test results. So a person could either have a disease or not have a disease. And then a test could either be positive or it could come up negative. If a person has a disease and the testing came out positive, that is a true positive value. If a person does not have a disease and the test came out positive, there's a discrepancy there, so this is a false positive value. If the person has a disease and the test came out negative, this is a discrepancy, so it's going to be false negative. And then they're both negative here, so it's a true negative value. We're going to tackle this table by looking at it as columns and rows. So for the columns, this first one is going to represent sensitivity. And this one over here is going to represent or measure specificity. Always put the true value as a numerator. So true positive goes on top, and that's true positive plus false negative. That's it. Specificity, same concept. Put the true value in the top and divide over the sum of everything. Now we're moving on to the rows. For the rows, and I'm going to write it over here, we have got positive predicted value for this one and negative predicted value for this one. So what does that mean? Always put the true value on top, true positive over true positive plus false positive, and then same thing goes for this one. You put the true negative on top over true negative plus false negative. So there we go, that's that. One last thing you need to know about this table is prevalence. I'm not going to teach you the equation for it. All you need to know about it is what the equation is trying to explain. Basically, prevalence has a direct relationship with positive predicted value, and it has an inverse relationship with negative predicted value. What does that mean? Well, as positive predicted value increases, prevalence will increase. As negative predicted value increases, prevalence will decrease. Let's move on to the actual equations that we need to know. Okay, we've got everything. So I just want to explain one thing about these two values. Odds ratio is a measurement during case control studies, and relative risk measures cohort studies. So what is the main difference between them? Very simple. So case control studies care about the disease status of the patient. Does this patient have a disease or does not? That is the starting point. Whereas the starting point of cohort studies is exposure. So for odds ratio, this one has no trick. A times D, that is A times D over B times C. And you can use as reference this table, and I'm so sorry I forgot to label it. There you go. Okay, relative risk. All it is positive predicted value over negative predicted value. So this right here, this row over this row. Simple. Another even simpler way to look at it is, since relative risk has to do with cohort studies and that has to do with exposure, you put exposed over non-exposed. This is actually relevant for exams. They straight up tell you sometimes this amount of people have been exposed, this amount has not. Boom, done. Okay, so attributable risk is going to be a subtraction actually. It's going to be positive predicted value minus negative predicted value. Or if you would like to look at it this way rather, it would be exposed, oh gosh, sorry about that, minus non-exposed. Simple. Now, relative risk reduction is the easiest one. It's just 1 minus relative risk. Okay, then we have absolute risk reduction is going to be the opposite of attributable risk. It's going to be negative predicted value minus positive predicted value. Or again, you could see it as non-exposed minus exposed. Another way event to look at this is non-exposed would be the control group, and exposed would be the people who are getting the treatment. Now the last two are number needed to treat and number needed to harm. Number needed to treat is 1 over absolute risk reduction, and number needed to harm would be 1 over attributable risk. Just remember that harm, the word harm, has AR in it. So that leaves absolute risk reduction belonging to number needed to treat. And that is it. Those are all the tips and tricks I have to offer for you today. I really hope it helps you guys as much as it helps me. I know it's a lot, so feel free to leave a comment below if you have any questions. Otherwise, thank you for watching my video and have a good day.